Friends, welcome to my channel. Dhanesh here.
In this video, we will implement the TFIDF scheme from scratch in Python. The term TF stands for term frequency, while the term IDF stands for the inverse document frequency. What are the problems with bag of words model? Before we actually see the TF-IDF model, let us first discuss a few problems associated with the bag of words model. We have the following three example sentences. I like to play football. Did you go outside to play tennis? John and I play tennis. The resulting bag of words model look like this. One of the main problems associated with the bag of words model is that it assigns equal values to the words, irrespective of their importance. For example, the word play appears in all the three sentences. Therefore, this word is very common. On the other hand, the word football only appears in one sentence. The words that are rare have more classifying power compared to the words that are common. The idea behind the TFIDF approach is that the words that are common in one sentence and less common in the other sentence should be given high weights. Theory behind TFIDF. Before implementing TFIDF scheme in Python, let's first understand the theory. We will use the same three sentences as our example as we used in the bag of words model. I like to play football. Did you go outside to play tennis? John and I play tennis. Step 1 is the tokenization. Like the bag of words, the first step to implement TF-IDF model is tokenization. You can see here. Sentence 1, sentence 2 and sentence 3 is tokenized. Step 2 is TF-IDF to find the TF-IDF values. Once you have tokenized the sentences, the next step is to find the TF-IDF value for each word in the sentence. As discussed, the TF values refers to term frequency and can be calculated. So TF values can be calculated using the formula TF is equal to frequency of the word in the sentence divided by total number of words in the sentence. For instance, look at the word play. In the first sentence, its term frequency will be 0.20 since the word play occurs only once in the sentence and the total number of words in the sentence are 5. Hence 1 by 5, it is 0.20. IDF refers to the inverse document frequency and can be calculated as follows. IDF is equal to total number of sentences, that is documents, divided by number of sentences, that is documents containing the word. It is important to mention that the IDF values for a word remains the same throughout all the documents and it depends upon the total number of documents. On the other hand, TF values of a word differ from document to document. Let us find the idea frequency of the word play. Since we have three documents and the word play occurs in all three of them, therefore idea value of the word play is 3 by 3 equal to 1. TFIDF values are calculated by multiplying TF values with their corresponding IDF values. To find the TFIDF value, we first need to create a dictionary of word frequencies as shown here. This is the word frequencies. You can see word I frequency 2, like it's 1. So let's sort the dictionary in the descending order of the frequency. Again, it's shown here. Now we will filter the 8 most frequently occurring words. As I said earlier, since IDF values are calculated using the whole corpus, we can calculate the IDF values for each word now. The next table contains IDF values for each table. This is the IDF values. You can see it here. You can clearly see that the words that are rare have higher IDF values compared to the words that are more common. Let's now find the TF-IDF values for all the words in each sentence. It's shown here. The values in the columns for sentence 1, 2, and 3 are corresponding TF-IDF vectors for each word in the respective sentences. It is important to mention that to mitigate the effect of very rare and very common words on the corpus, the log of the IDF values can be calculated before multiplying it with TF-IDF value. In such case, the formula for IDF will be this formula you can use. IDF will be log total number of sentences, that is documents, divided by number of sentence documents containing the word. We need to take the log of the previous this one. So since we had only 3 sentences in the corpus, for the sake of simplicity, we did not use the log. In the implementation section, we will use the log function to calculate the final TF-IDF values. In this table, we didn't use. See, let's do the TF-IDF model from scratch in Python. As explained in the theory, the steps to create a sorted dictionary of word frequency is similar between the bag of words model and TF-IDF model. To understand how we create a sorted dictionary of word frequencies, I will explain here. The TF-IDF model will be built upon the Python, and I will be using NLTK, NumPy. These are all the libraries I am using. TF-IDF algorithm. We call it as word frequency algorithm as well. TF-IDF algorithm or word frequency algorithm. TF-IDF stands for term frequency inverse document frequency. This is a technique to quantify a word in documents. We generally compute a weight to each word which signifies the importance of the word in the document and corpus. This method is widely used. It is a widely used technique in information retrieval and text mining. And it is easy for us to understand the sentence as we know the semantics of the words and the sentence. The computer can understand any data only in the form of numerical value. So for this reason, we vectorize all of the text so that the computer can understand the text better. Now we will see these are all the terms this is the math of TFIDF. See, TFIDF, that is equal to, this is the equation you need to understand. TFIDF is equal to term frequency into inverse document frequency. Term frequency is TF. I will tell you what is term frequency. We will be discussing what is inverse document frequency. IDF we are going to discuss. See, T, the letters we are using, T means term or a word, term or word. D means document or set of words. N means count of corpus, and corpus means the total document set. These are all the letters we use in the coming discussion. So the TFIDF, the formula for TFIDF is the term frequency into inverse document frequency, IDF. Let's get into, try to understand term frequency. This is very simple. See, this measures the frequency of a word in a document. Term frequency measures the frequency of a word in a document. When we are vectorizing the documents, we check for each word's count. In worst case, if the terms doesn't exist in the document, then that particular TF value will be 0, and in other extreme case, if all the words in the document are same, then it will be 1. The final value of the normalized TF value will be in the range of 0 to 1. Now, term frequency TF is how often a word appears. See, in the simplest way, we can define term frequency TF is how often a word appears in a document divided by how many words there are. For example, the formula for term frequency is number of times term or word T appears in the document, the whole divided by total number of terms in the document. For example, you have a document with 1000 words in that document, and you want to find out the term frequency of the word, pen. You want to find out the term frequency of the word pen. So pen is repeated how many times in the document? Let us assume that it is repeated 10 times. If it is repeated 10 times, how do you calculate? It is 10 divided by 1000. It is 10 divided by 1000 is the answer. See, what is 10 here? For example, you are calculating the term frequency of the word pen. This is the word P-E-N. The term frequency of the word pen in the document. The word pen repeats 10 times. Number of times the word pen comes in the document is 10. The total number of terms in the document is 1000. Then what is the term frequency? It is 1. This is equal to 1 by 100. This is the way you calculate it. This is term frequency. Now I will discuss document frequency. This is rarely you use, and I will explain what is document frequency as well. This measures the importance of document in whole set of corpus. This is very similar to the term frequency. The only difference is that TF is frequency counter for a term T in a document D, whereas DF, document frequency, is the count of occurrence of term T in the document set N. That means DF is the number of documents in which the word is present. So that is another term you will use in this algorithm, that is document frequency. See, another important point, this is really important, you need to understand here, is the inverse document frequency. See, what is inverse document frequency? See, we already discussed term frequency is how common a word is, how common the word appears in a document, that is term frequency. Inverse document frequency, IDF, is how unique or rare a word is, that is inverse document frequency. The equation for inverse document frequency is logarithm of total number of documents, the whole, divided by number of documents with term T in it. That is the formula. See, you have the log of total number of documents. See, logarithm of, it's a log to the base e, it is not underscore, it is log to the, it is, the formula is log to the base e. Here, then total number of documents divided by the number of documents with term T in it. This is the inverse document frequency. For example, if you have 10 documents, see, you have the total number of documents with you is 10. This is 10. Number of documents with term T in it will be, you can see, let us assume, more easier way. I will, then it would be more. See, let's assume that we have 1000 documents. The number of documents with term T in it is, we have only 10. So you will take logarithm of 1000 divided by 10. Logarithm of 1000 divided by 10. See, what is logarithm of 1000 by 10? That is log of 1000 by 10 is 100. Right? What is logarithm of 100? It is 2. So 2 is the, you can take it as the inverse document frequency. Inverse document frequency is how unique or rare the word is.
Thanks for watching. Please like, share and subscribe. Thanks a lot.